All right, so now we're moving on to inverse properties. These are really special because they can help you get rid of stuff really easily. As we know, exponential and logarithmic functions are inverses, and since they are inverses, they undo each other, just like if I squared a number and then I took its square root. I'm just getting myself back to the beginning. Okay, if I added 4 to something and then I subtracted 4 off, well, I'm right where I started. So when you have logarithms and numbers that are exponential, then you're ending up undoing stuff. And that's what's happening right here. That's what's happening right here. You have a log with a base b, and then of the value, that value is acting as a base of the power form. It's acting as the base with some exponents. If these two bases are the same, then we know that that value here of the log is 1. In the last video, we moved the x down to the front, and we said x times log of whatever base of this number. Well, think about it. Let's just pretend like this is a 5. In both cases, the b's are 5s. If I brought the x down and I said, what 5 to what power gives me 5, you would say 1. Therefore, the leftover would be x times 1, which is just x. So we don't have to go through all of that to get there. We just now can apply a property that says if we see a base here that's the same as the base here, then we'll know that that will undo each other and we'll just have x that's left over. Same thing here. This big B here is the base, and up in its exponent is a logarithm, which is undoing the exponential form, and it's undoing it because this B here is the same as this B. It can be canceled and we'll just have the x left over. Okay, so this big B has an exponent of a log, which will undo this whole power. Okay, let's see if we can do this. So we see a base here that is the same as the base being raised to the 11th power here. So this cancels out and we will just have 11. Okay, now this one here is not written like that one was, but I can force it to be rewritten that way because I can say log base 3, and I know 81 can be written as 3 to the 4th power. Now I have log base b of the same b value being raised to the 4th power, and those will cancel and I'm left with 4. And then over here, 5 is the base, and in its exponent is a log with the same base. So because exponential and logarithmic forms cancel each other out, they're inverses, they undo each other, I'll just be left with 10 in this problem. Okay, that's all for this video.